Hello guys, so this is an introductory video for Hyperledger Fabric. So in this session, our goal is to build a Hyperledger Fabric application. We'll be doing many things to interact with the ledger, but first off we will start with the introduction to Hyperledger, then we'll get introduction to Hyperledger Fabric. We will also go over some of the basics of Fabric, like what an MSP is, what a peer is, how transactions are committed, what an ordering service is. Once we're done with that, we'll dive into coding. Hyperledger Fabric has some prerequisites. So in session 2, we will go over installing Go, Python, Node.js, and NPM. We'll also install Docker and Docker Compose. Once we're done with installing the prerequisites, what we'll do is we will install Hyperledger Fabric. So first off, we'll download the Hyperledger Fabric sampler repository from GitHub. Then we will set up Hyperledger Fabric and Hyperledger Fabric CA. Hyperledger Fabric CA stands for Hyperledger Certificate Authority. So in this tutorial, we will use the default certificate authority provided by Hyperledger. Once we're done with that, we will set up a Docker image for our Hyperledger, and then we will dive into the code and see the directory structure for how code is organized for Hyperledger Fabric. Once we're done with that, we will dive into the Fabric application. So what Fabric application is it's a ledger of cars. You can think of it as a database that consists what a car is and who the owner of a car is. So first off, we'll set up the application, then we will register an admin, which is basically an MSP. Once we have an MSP set up, we will register users. We will also modify the code to see how we can register random users. Once we're done with that, we will query the ledger. So in querying the ledger, we will pull up the details on cars, like all of the cars, and we'll also try to pull one car. In the last session, we will interact with the ledger. We will look at the chain code, and we will see how to update the state of an object on the ledger. So in the updating the state, we will first we will do a normal update, and then we will transfer the ownership of a car from one person to another person. So this is basically the overview of what we're going to do in this tutorial. I hope you guys enjoyed the tutorial. Hello, in this video we are going to learn about Hyperledger Fabric. Hyperledger is an open source blockchain technology developed by Linux Foundation. Hyperledger runs many projects like Burrow, Califer, Cello, Fabric, Indy, Iroha, and Quilt. In this video we are going to learn about Hyperledger Fabric. Hyperledger Fabric is an open source blockchain technology. Hyperledger Fabric is a permission blockchain, which means you need to have permission before doing any transactions on the network. Fabric is a very powerful tool and can be used across many businesses. Some of the prerequisites before starting development on Hyperledger Fabric are Go, Python, Node.js, and Docker Compose. Make sure you have the latest version of all of these four installed. You will also need to install Git. Okay, so in this session we're going to go over basics of Hyperledger Fabric. So there are several key concepts for Hyperledger Fabric. The first one is the Hyperledger Fabric is a permission ledger, which means for anybody to come on the ledger, they need permission. So who provides this permission? So a permission provider is basically an MSP. MSP stands for a member service provider. A member service provider can be either a peer or an authentication service that stands between the network and outside users. So what MSP does is it validates all the users. It also authenticates the users, and it allows access to new users. So let's say somebody wants to come on the network, they have to contact an MSP, and the MSP would validate KYC if needed, and then they will allow the user to communicate with the network. Hyperledger Fabric Network is run by peers, and peers are also validated and authenticated. What peers basically does is they act as a miner. They act as miners, like in Bitcoin or Ethereum network, there are miners who process transactions. So peers perform the same. Peers basically perform the same things. On the network, you have proposals. So if a users want to make a change, they have to contact a peer, and then a peer basically proposes a change to the network. This proposal is basically, basically what a proposal is a proposal is basically change of state to the network. So network holds a global ledger, and the global ledger contains assets, asset types, and who owns that asset. And a proposal is basically a code that proposes transfer of those assets from one user to another user. Another key concept is endorsement. So what endorsement is basically when you endorse a transaction. Committing is when you commit a transaction to the blockchain. So endorsement and commitment are performed by peers. They can be performed by the same peer, or they can be performed by different peers. In traditional blockchain, what happens is all of the transactions gets combined into a block by miners. Proof of work and proof of stakes are great systems, but they slow down the ordering of the transactions. So on Fabric, we have a third service. It's called the ordering service. So what the ordering service does is once it receives transaction, let's say 1,000 transactions, it orders them in a sequence. Once that sequence is done, the ordering service combines that into a block. The ledger here is a global state. So you can think it off as a key value pair that everybody can see. In Hyperledger Fabric, we also have channels. So channels basically define the relationships between different peers, different users. A channel can be a private channel, or it can be made a public channel. So if two parties transact and they don't want everybody else to see their transaction, they can open up a channel between them, and all the transactions on that channel would only be visible by the two users. So this is basically how a Hyperledger Fabric network looks like. So you have an outside application. This application can use an SDK, an API, or it can be a native application. So if a user wants to come on the network, what they do is they send their registration information to MSP, and then the MSP contacts all the peers talk to each other, and they decide whether the users can come on the network or not. If the user can come on the network, the MSP sends back a certificate to the user. Now this certificate is basically like an account ID and password. If you want to get on the network, you have to have the certificate. This is how the Hyperledger Fabric network works. So you have a user application. This is a distributed application. This application allows users to communicate with peers. However, here in between user and peer, there is also an MSP. Peer can be an MSP as well, or you can have a dedicated MSP. Once the users wants to contact a peer, they also send a certificate with them, and MSP validates that certificate. If a user wants to commit a transaction, what they do is they propose a change to the global state to the peer. Then the peers basically runs a chain code and decides whether the transaction can be done or not. If the transaction can be done, then the peers, regardless of whether the transaction can be done or not, the peers send a signed response back to the user. This response contains whether a success or failure of the transaction. Once peers receive the transaction, what they do is they act as endorsers or committers. If a peer, let's say a peer is an endorser, right? So that peer would endorse the transaction. It will send out that transaction to all the other peers. All the other peers validates that transaction, and then the transaction gets sent to the ordering service. A lot of peers simultaneously sends a lot of transactions to the ordering service, and then what the ordering service does is it creates a sequence of transactions. Once the sequence of transaction is done, the ordering service sends these transactions back to the peers. This sequence basically is a block. Now once that is done, peers commits this block to the global ledger. If a transaction is committed in a private channel, then the peers only updates the global ledger. They don't put the transaction by itself in the ledger. Now once the transaction is on the ledger, the users can basically check the ledger via the peer, or they have a direct access API which they can use to see the ledger. Before we dive into Fabric, we need to install some prerequisites. Prerequisites for Fabric are Go, Python, Node, JS, and NPM. We'll also need Docker and Docker Compose. We'll start by installing Python. We'll open a terminal here and just do sudo apt get install Python. We can check if Python is working by typing in Python. So now we have the Python console here. The second thing we'll need to install is Go. So we'll just do sudo apt get install Golang. Go is a language developed by Google, and it is very useful when we have parallel computing. A lot of companies and a lot of people use Go for statistical analysis because it can run processes in parallel. So basically, you can run a cluster of Hadoop or Spark very easily in Go. Go is also a functional language. We'll see if Go works. Go version. Well, version is not right command. It's not the right command, but we can see Go is set up here. The next thing we'll need to install is Node.js and NPM. We have to be careful here because Fabric does not allow any Node version higher than 8.12, I think. So we'll need to set up the latest 8 version. So to do that, we first need to fetch it from the server. So now we have Node here already, so we'll do this. We can check if Node is working by typing in Node -- version. Okay, so we have 8.12, which is the latest 8 version for Node. And let's check what version of npm we have. Obviously, we have a npm version 6.4.1. Obviously, my bad. Node Fabric requires a Node version 8.9.x. We just installed a Node version 8.12. So what we'll do is we will remove this version first, and then we will install 8.9.x. What we'll do is if you run this command without auto remove, it would not remove the whole node package. What it will do is it will remove node related binaries, and some packages like gyp will not be deleted. So what we'll need to do is we'll need to pass this argument called auto remove. This will also remove gyp. So now once we have that removed, what we can do is we can download 8.9.x. That didn't work. Let's try 8.9.3. No, hold on. Okay, actually, you know what? 8.12 would work, so we would just install it again. Let's check our npm and node versions. We have the latest node version, and let's see npm. We have the latest npm version as well. So our node setup is finished at this point. Now what we'll do is we'll set up Docker. For Fabric, we can use Docker CE. So we'll just download Docker. Obviously, installing Docker is not as easy as you just did. So I'm just gonna copy the link here, so you can follow how to install it. Once you visit the URL, it has all the steps required. So what this command will do, it will add Docker's official GPG key. Okay, and then we'll have to match the fingerprint. Okay, let's see the fingerprint 9C5822. After the fingerprint matches, so now we have the correct version. And let's see.
recording guys?
Because now Docker is installed, so let's run hello world container. It says a hello from Docker, so this means that Docker CE is installed. Now what we need to install is Docker Compose, so we'll use this command. If we go to user local, we can find a copy of this Docker Compose. Here we see Docker Compose. It does not have an executable permission, so what it will do is we'll give it an executable permission. Okay, so now Docker Compose have an executable permission. So now our prerequisites are all set up. We can dive right into setting up Fabric and our test application, which is FabCar. Okay, so in this session we will download Fabric and Fabric samples. So we can just clone this repository. You need to create a directory for Fabric. After that, you can clone it. So let's see. Okay, so we have the Fabric samples already. Now what we need to do is we need to download Fabric CA, and a third-party Docker image, and we'll also run bash to install it. Installing Fabric and Fabric CA is gonna take a while because the file size is very large, so we're just gonna wait here for it to be downloaded. Okay, so we need to run this command using sudo. Sorry about that. There seems to be some permission issues here. So let's see what the issue is. So the issue is the permission is denied while connecting to Docker daemon socket at Unix or run Docker socket. So let's see. So what we did here was we updated the user mod. So let's see if this works out. Let's try to switch user. Okay, so this command we need to switch user to the root user. I think one of the problem is since we're installing a Docker image, it's gonna update some some of the files on the some of the Linux kernel files, right? So for that we need to switch users to the root. And the other thing, what happens is that once we run a command with sudo, if there is a sub command, it might not run it. So the better approach is to switch user to root. Now this is gonna take a while, so I'm gonna pause the video here. Okay, so the first thing we're downloading is Fabric Peer. So as we mentioned in the introductory video, what a peer is, a peer is basically a miner, right? So what a peer does is it serves all of the users. A peer can be an MSP service provider, or they can be validator, or they can just be an ordering service. So right now we're downloading the Fabric Peer. So once that is done, we're downloading Fabric Orderer. So what Orderer is if you're familiar with traditional cryptocurrencies such as Bitcoin and Ethereum. What happens in Bitcoin and Ethereum networks is user submits their transactions on the network, and all of the miners, they get all the transactions and they create a tree, and then they order it in the tree. This approach is good. It's very secure, but it's not feasible when we come into corporate world, because companies might have millions of transactions happening in a minute, right? So it's very important to separate the ordering services from peers. Right now we're downloading Fabric CC environment. This is going to take a while, so I'm just going to pause the video. It's been a couple of minutes and we're still downloading the environment, and we're still installing it. I'm just going to pause here. Okay, so the CC environment has been installed. What has been installed is Java environment as well. And now we're installing Fabric tools. So one great thing about Fabric is it comes in many different languages. So you can use Node, you can use Go, or you can use Java to program your chain codes. Now we're installing Fabric CA. So what Fabric CA is, it's basically a certificate authority. So once a user comes online or a peer joins the network, they carry a certificate, so they can be validated, they can be authenticated, and the network can know that they're valid users. They're not just some fake people trying to bring the network down, right? And basically Fabric CA can be like a server. It shares all the user identities across the network. So anybody who's on the network, the CA server would have details of them. Now we're installing Fabric CouchDB. So CouchDB is basically a database. So CouchDB is not like the ordinary MySQL database. CouchDB is more of like a MongoDB, right? MongoDB is document oriented, NoSQL database. The same thing goes for CouchDB. One great thing about CouchDB is that it's easily scalable. That means, I mean, it's something that a blockchain network would need, because if transactions get scaled up or down, the database needs to be scaled up or down as well. If a lot of user comes on the network must have the ability to facilitate all the transactions done by those users. So that is a reason why we use a CouchDB with Fabric. After CouchDB, we installed Fabric Kafka. So one great thing about Fabric is you can plug and play. You can use different algorithms for clustering, for ordering, right? And what Kafka is basically a distributed, horizontally scalable. It's also fault tolerant. It's a commit log. So what commit log means is it's a message handling system. And the great thing about Kafka is you can only append data to it. So once you add data to Kafka, you cannot delete it, or you cannot even update it. All you can do is you can transfer ownership from one owner to another owner, which is what we try to achieve in blockchain. Okay, so now our Fabric environment is set up. So what we've installed here, let's see what we've installed. So basically installed a module for Fabric Peer, Order, CC environment. We've also installed Java environment, some tools, certificate authority, CouchDB, Kafka, and Zookeeper. Fabric is written in Go, so you wouldn't see a Go module here because it is written in Go. Okay, so that's it for this session. In the next session, we will go over a basic Fabric application and how Fabric works. Is downloaded and installed. What we can do is we can jump right into a Fabric application. So here we're going to look at a sample application called FabCar. So what FabCar is it contains a database of a lot of cars, and it also has owners, right? So you can think of this application as a government service that holds records for who owns which land, right? So initially we have 9 to 10 data entries into the system into the network, and what we can do here is we can add new users. We can transfer ownerships, which means like if person A sells car to person B, we can record the transaction on the blockchain, and both of those persons can show it to somebody else that, hey, okay, I did this transaction and this is the receipt of the transaction. So let's dive into the FabCar application. One thing first we'll need to do is we'll need to update the path variable. So let's update the path variable. We'll and now let's check if the path variable is updated or not. We see right here that Fabric sample, the path has been updated and Fabric sample is on the path. Now before moving forward, if you're doing this tutorial second time, what you'll need to do is you need to kill all the stale and active Docker containers. We're going to do this in this tutorial anyways for the safety. I don't know, Docker is giving me trouble on this computer, so we'll open another terminal and perform Docker commands using root user. So by doing this, we have killed all the active and still Docker containers. Now, if you're doing this tutorial the second time, this is a command that you need to install. Sorry, you need to execute in order to kill. There is one more Docker image, which is the admin of the previous network, right? So it has to be removed before we can move forward and add another admin. Since we're doing this tutorial the first time, we're not gonna execute this command. Okay, so once we are in the Fabric sample directory, we can see FabCar here. Okay, so let's see what we have. We have balance transfer here, the first network. We have basic network, config, high throughput, scripts, bin. Chaincode. This command, this folder contains a lot of chaincode. The FabCar, this is the application that we're gonna work. This is license, Fabric CA. Fabric CA, as we mentioned earlier, is certificate authority. And here we have Chaincode Docker. If you're developing, you need to develop in Chaincode dev mode. So let's move into FabCar. So in FabCar, we have several .js file, but first we need to install this application. npm install would do. This is going to take a while. So here, the application that we downloaded, it contains .js files, which means it's you can use Node.js to execute them. You can also write the application in Go or Java, whatever you prefer. But I recommend using either Go or Node, since Go is something that not a lot of people know. Node is the best option because since we can find online forums. Okay, so our FabCar application has been installed. It installs a lot of modules, so let's make sure that everything is installed. See, there are some warnings, that's fine. There's some notices as well, that's fine as well. Okay, so our FabCar application has now installed. So now let's look at the directory we have. Okay, so we have enroll admin here, invoke.js. There are some node modules in this package. We have register user and query.js. So let's go over what all of these files do. So enroll admin is basically when we start the network, we need to enroll an admin. So admin would be basically an MSP, right? So without an MSP, you cannot operate a network. You need an authority who tells which users or which peers can enter the network or transact with the network. So it is one of the most important part here. Then what we have is query.js. So what query.js does is it queries the network for specific things, like you want to find out who owns which car, or you want to just query everything related to a car. So we'll do that in query.js. Then we also have a register user.js. So what this file does is it registers a new user on the network. Invoke.js is basically it updates the global ledger, and start fabric.sh. This is the bash file that will start the network. So we're going to finish this part of the session right here. In the next session, we're going to jump into the chain code, and after that session, we'll go into the details of what these files does, and we'll execute our own commands. Hello guys, so in this video, we're going to go over how to start the Fabric network and how to enroll an admin. So the first thing we need to do is we need to start the network, which we can do by starting /start fabric.sh. What this will do is it will bring up the network. I've preloaded everything already because it takes a while for the network to come on. Okay, so once the network is up, we can see what is coming up. So this is basically creates the CouchDB. The certificate authority is ca.example.com. Certificate authority is very important in the network here, because for any user or peer to communicate with each other or with the other peer or user, they need to have a certificate. Then we have auto example, and on this red network right now, we only have one peer, which is peer0.org1.example.com. If we scroll down here, we can see that Chaincode has invoked successfully, and the status is 200, which means the server is running fine. If we want to see the logs of the Docker, what we need to do is we need to type in docker logs -f ca.example.com. What this command will do is it will capture everything on ca.example.com docker. So now we can see that the config file is stored here, etc Hyperledger Fabric CA in this folder. We're just going to use the default configuration for the network here, but if you want to change something for your network, particularly like you want to use Zookeeper instead of Kafka, or you want to use something else for proof of work or proof of stake, you do need to modify the configuration file. The CA server location is here. The CA certificate file already exists. We can see right here that we have signed a certificate. The CA server has signed a certificate as well, and it's listening on 7054 port. So everything seems good here. Our network is up, and our certificate authority is up as well. So here now, what we need to do is we need to enroll an admin. Enrolling an admin is very important because this will initiate an MSP. We do need an MSP before doing anything else, because as we have seen, Fabric is a permissioned ledger. It's not a permissionless ledger, which means there needs to be an authority who determines who gets on the network and who does not get on the network. to enroll admin, we can just simply do node enrolladmin.js. What this file will do is it will create an admin. It will create a certificate for the admin. It will store it in the HFT key store folder. Okay, as we can see here that this we have successfully enrolled the admin, and the MSP ID for the admin is org1 MSP. It has no roles, affiliate 0, enrollment secret, signing identity. We have the signing identity here. We also have a certificate. Let's see where the certificate is. Okay, so this is the end certificate. There should be a begin certificate. Okay, so this is the certificate that the CA server has generated. Excuse me. Okay, now let's go into the enroll admin file and see what code we have there. Okay, we're right here. Let's see, this will require an import. Fabric client is important. So Fabric client is basically a class. You can create a new instance here. Fabric CA client is also a class. You can create a new instance, or you can request a network to get a client. Now we see here that our store path is HFC key store. Now this folder contains, well, basically for this tutorial, since we're doing everything on a local computer, everything will be stored in HFC key store. But if you are on a network, everybody will have their own key store folder where they can store their public and private keys. You can choose any random folder if you want to, but here we're just choosing HFC key store folder inside the directory we're working on right now. So now here we're invoking a new method called new default key value store, and the path is, so it takes, let's see what arguments it takes, because it takes path as one of the, it only takes path as one of the argument, so it will store everything on this path, and then we're setting the state of the network here. We're getting a new instance of CryptoSuite, right? And CryptoSuite will generate a new public key and private key. And as we can see here, and this is, as I told you earlier, Fabric CA client is a class, so we're creating a new Fabric and creating a connection to the CA client here. Now this comment is only if we are on a TLS enabled server, which means we need to use HTTPS instead of HTTP. Now here we successfully loaded the admin. Now this checks that if the admin is already enrolled or not. If the admin is already enrolled, we don't need to enroll a new admin. If the admin is not enrolled automatically, it's not, I mean, if the admin is not enrolled already, what we need to do is we need to create a new admin account. So here we're going to use Fabric CA client.enroll method here, which will enroll the client. So I'm sorry, not the client, the admin. The admin. If it is successful, then we just print out the message, okay, successfully enroll the admin. The username would be admin, and this is the MSP ID. And also we have the key and the enrollment certificate here. If for some reason this method fails, we can catch the exception, and we can say, okay, we failed to enroll a persistent admin. Okay, so that's all for enroll admin class here. We might want to take a look into Fabric CA client and Fabric client. So let's see where they are. This is the README for Fabric CA client. Oh, sorry, my bad. This is only, yeah, Fabric CA client. It's quite long, and but we you get the basic idea. So here, if we go into the sample directory, we can find all the functions that we've used. We have balance transfer, basic network. We have the Fabric CA server here. We also have the first network. This is also another example. Okay, and we also have scripts. Let's see what we have in scripts. We probably shouldn't touch this. Let's go back to FabCore. We can see Chaincode if we like to. Okay, so the Chaincode comes in, well, it comes in 3 different languages: Go, Node, and Java. So we'll look into Node because it's something that most people understand. So we have fabcore.js. So this is our Chaincode for the network. It has a lot of code, and we're going to use some of the functions that are in here, like querying the car or an invoke. See, the ledger is initiating here, so we'll go into initializing the ledger, and then we'll come back here. This is the query all cars function. This is the change car owner. You'll use this function if you want to change the ownership of the car. Let's go into HFC key store folder as well. So as we can see, we have the admin user here, and we also have public and private key for the admin user. Now, if we're gonna add any new users, the credentials are gonna be stored here, since we're working on a local network. So that's it for this video. In the next video, we're going to initialize the ledger, and we'll see if we can query the network. Okay guys, so in this session we're gonna go over creating a new user, registering a new user. We will also query the ledger. So let's go into let's first add a user. Register user. So we'll just do node register user.js. This should register a user. Okay, as we can see, user 1 is registered. This is the secret for the user. The name of the user is user 1. And the user is ready to interact with the network. So we can see here that there was a post request made on the network, and the HTTP status is good. Everything is good. And we can also see that it's signed certificate with serial number. This is the signed certificate. So one thing about Fabric Network, as we discussed earlier, is that for every transaction, if you want to communicate with a peer or with another user, you need to have a peer sign the certificate or the MSP sign the certificate. Okay, so now we have the user registered. Let's see in the HFC folder. Okay, as you can see, we have the user 1 registered here, and we also have the private and the public key for the user. Now let's go back and see what we have in register user.js. Okay, so we're right here, register user.js. We're creating this is just require. Everything is required. We're storing the secret for the user in HFC key store folder. Let's see. Okay. we're using the default configuration file. Okay. So first of all, we need to load the admin. So as we discussed, admin here is basically the MSP. Since this is a permissioned ledger, we need permission of the admin to register a new user. So as you can see right here, that we need to get the user context of the admin, and once we have, wait, we're in the registry user, yeah, right. Once the user register a user. So as you can see, Fabric ca.client, we're registering a user with user 1, affiliation, organization 1, department 1, role of the user is client, and we can define role of any users, and we can change affiliation of a user. And role of a user can be, the user can be an employee, it can be a trader, and the affiliation can be like what department they're in, like human resources, or what type of business they run, or what type of functionalities they play, what type of roles they play in a business chain. So here we're registering the user 1 successfully. The enrollment ID is user 1. Okay. So everything looks good here. So let's try to enroll another user. Let's try to enroll user 2. And let's give them organization 1. They're in department 2. Let's give them the role of I don't know, accountant maybe. This user will be accountant, and this will be the secret. The enrollment ID is user 2. Successfully enrolled the user 2. I mean, everything is hard coded here, so we just need to change everything. Let's save this and let's run it again to see if user 2 gets registered. Where are we? Okay, so we'll just do node register user.js. User 2 was successfully registered and enrolled and is ready to interact with the Fabric network. We can see if the user is registered by going into HFC key store folder. We do ls-al, we see right here that the user 2 is registered, and we have the public and private key stored. Now, this is a simple way to register a user. What else we can do is we can create a web interface where users enter their username and password, and we can store these public and private keys in some secure location, and that so that it can only be unlocked after a user is authenticated. So let's modify register user to generate a random user like user 3 or user 4, right? Okay, let's do that. We're going to generate a random string, and we will use this to generate a random string for the user. So let's open up another terminal here. Okay, we can do npm install. There is a package, I believe, in npm that creates random strings, random string. Let's see. Yep, there we go. Random string, yeah. We're just going to use this function, use this package to generate random strings. Okay, so it has been added, and we just require I'm just gonna copy everything from here. Oops, not here. Key edit. Okay. We're gonna name for our user, and let's generate a username with 8 characters. Okay, and here where did the user go? Oops, no, we're in the wrong file. Sorry about that. Yes, so let's open the registry user first. No, we're in the wrong directory. Okay, here we're just gonna copy and paste, and we're gonna name our variable username. Let's enter the username with 8 characters, 8 random characters. We'll have to modify successful. Okay, so there is, okay, so the username here should be the username, not user2, because that would create conflict here, because we are registering the user. Okay, enrollment, this user2 would be updated to username as well. And username, okay. Oops, sorry. Let's run it again. Let's run it again. Okay, so we see we added a new user, Mark. It's MARQEQG1. We can do it again. We can add as many users as we want. Let's add a bunch of users here. So Okay, let's go to HFC key store. We can do ls minus al. So as we can see, all the privates and public keys are stored here. Now let's look into what these users have. Is there one? No, I can't do that. Yes, I can. Okay, so if we open any user, what we get here is we have the name of the user, the MSP ID, what role they have, affiliation. Affiliation is null here for some reason. Secrets, signing identity. We have their identity. For their identity, we have their certificate. So this is a begin certificate. And the end certificate, this is basically the identity of a user on the network. I don't know why the affiliation is null here. Let's see if any of the other users have the same thing. Yep, the affiliation here is null as well. The role is null. The affiliation is empty. Let's see if we miss something. Oh no, we have that open already. So we're just gonna go to registry user. Okay, yeah. So in Fabric CA, we need to set affiliation. Okay, so this is all business related. So we need to set affiliation predetermined. We can set that in Fabric CA. Since we tried ABC, it's not something that is already added in the affiliation. So okay, so org1.department2 is something that is already in the affiliation. So we can register a new user here. Okay, yeah, so a new user has been added. Okay, so now what do we do? What are we gonna? So that's it for this video. In the next video, what we're gonna do is we're gonna look into query.js, where we are going to try to query the ledger. This video we're going to look at query.js function JS file. So let's first query the network. So as you can see, when we queried the network, we got key value pair of all the cars. We got cars 0, 1, 2, 3, up to 9. So let's look at query.js file. Because we got the query.js file here. We do need to define a channel, because as we discussed, if you want to communicate with the network, you can only communicate within a channel that you're in. You cannot communicate outside of that channel. And this is the peer that we registered already. Let's look at the log. So the first peer that was registered was on 7054. Let's see, what is this? 7051, no. Well, and anyways, this is the wait, where do you go? Okay, so this is the peer that we're going to communicate, that we're going to be communicating. we're going to load the HFC key store file. We have the TX ID here, the transaction ID here, and this is just preloading. We're just gonna load the certificate from the HFC key store. Then we're gonna set the crypto suit, and once that is done, we do need to make a request, make the query using a user. So the first user we created was user 1, so that's what we're gonna use here, the chaincode ID. So this is the actual request that we're gonna make. So chaincode ID here is the chaincode that we're gonna use, and the function we're gonna use, which is query all cars. So what this function will do is it will query all cars. Okay, we also have that's it. So let's look into the actual chain code that this request is going to execute. Okay, let's finish this file first, and then we can move on to the chain code. So here, as we can see, once we create a request, we need to send it to a peer. So here we're sending this method to a peer, and a peer is giving us a response like, okay, the query has been completed. It either gives us a response or it gives us an error. Now let's look at the chain code and query all car function. Okay. Okay, so this is the actual chain code for fabcar.js. Okay, we were trying to go on query all cars. Okay, let's see how this works. Hold on. Success. We got method, function name, receive. Okay, so this function is the ledger function. So what this function does is it initializes the ledger. So here we have a list of cars, right? So and we're basically pushing all of these cars on the list. So we got Toyota, Prius, Blue, Tomoko. We're pushing all these cars in the list. Once that is done, we're putting the state on the ledger. So on the ledger, we can do three things. We can either put a state on the ledger, we can update a state on the ledger, or we can get a state on the ledger. So here, since we're initializing, we need to put all the states on the ledger first. So what this does is that it iterates over the list, and we're putting these cars one by one on the ledger. Okay, now let's go to query all cars. So when we put something on the ledger is basically a key value pair. So the key here is car plus I, which is car 0, 1, 2, 3, and the value is this JSON. Well, it's basically, yeah, we're basically converting this into JSON. So it would be the JSON data of the car. Using key value pair, it becomes very easy because all of the assets have their one key, and you can have as many elements as you want for the value of that key. Since this is JSON, you can add as many properties as you want. Okay, so this is the query all function that we just used in the query.js file. So the first thing we have is we have the start key and we have the end key. We also have the iterator operator here. Once that is done, we're here. What we're doing here is we're creating an empty list. And while we're through, we're getting the next element on the iterator. If there is a next element, then continue. Wait, where is? And here we're getting all the value. We're getting the value from the ledger. We're basically parsing the values. Well, here when we get the iterator, we're getting state by range. There is this function called state by range that Fabric provides. So what this basically returns is it returns all the states between the start key and the end key, and it gives us an iterator. So we're going over the iterator and we're printing the results. Okay, there is also a function to query a car. Let's see where that is. Okay, there we go. Query a car. So what this function will do is it will query a single car. So what we need to provide is we need to provide it a car number, which is basically our key for the key value store, and we're getting the state by the car number, and we're just printing if the car actually exists or not. Okay, so let's go back to query.js and modify this function to query just one car. Okay, so as we can see, here we have requested data for only one car. The car number was car 0. Let's try to modify this and request a car that is not on the ledger, like car 99. Oops, sorry about that. As you can see, we have requested the network to return car 99, but since car 99 does not exist, all we're getting is null. Okay, so that's it for this video. In the next video, what we're gonna do is we're going to look at invoke.js file, and we're also going to look at the chain code for invoke.js. And what invoke.js will do is it will transfer the ownership of a car. Okay guys, so in this session we are going to go over invoke.js. So what invoke.js is, what we can do with invoke.js is we can change the state of the ledger. So let's see, let's first execute invoke.js. Okay, so we're executing the transaction using user 1 here. The proposed transaction proposal was bad, failed to send proposal or receive valid response. So so when we want to make change to the ledger, what we need to do is we need to propose a transaction to the network. Then what we do is we send this proposal to a peer, and then the peer validates it, and then it sends it to an ordering service. If everything goes well, we get a successful transaction execution. But everything didn't go well, so let's see what happened here. Okay, since this is not there, so there is no error with this with certificate authority. So the error must be for proposal. Let's see what the error is. Let's try to debug it. Okay, so we have invoke.js. Let's go over this file line by line so we get a better understanding. So this is just requiring everything. This is our Fabric client. This is the channel that we're working on, and this is the peer that we're working with. So in the channel, first we need to add a peer. So the way channel works is we create a new channel, then we add a peer, or we add multiple peers, and or add multiple users. Once we have the channel set up, then we can start communicating with the network. Okay, so the ordering service is localhost 7050. Maybe we're missing a no. That's probably not the error. And in the channel, we're adding the order. We're adding the orderer as well. So once we create a channel, what we do is we add peers, we add users if we need to, then we add an orderer. Okay, so now let's go into the next line, member user. Everything is null here. We're going to use the HFC key store folder to load up private and public keys. We're using the default configuration. Okay, this is just the basic, loading up the crypto suite and everything. We're using user 1. Once the user 1 is loaded completely, what we do is we can request Fabric client a new transaction ID. So by doing Fabric client dot new transaction ID, this will return us this will give us a new transaction ID, right? And we can use this transaction ID to propose a new transaction on the ledger. Okay, and this is a request. Okay, so the error is we are not requesting any function here, right? Because we're using the chain code here. The function you see right here is empty. So we need to update this, and let's try to create a car first. Let's put a new car on the network. Okay, so we're gonna use the create car function here. And let's name our car 14. We're just going to hit save here and we'll execute. Okay, so as we can see here, that proposal was good. Successfully sent proposal and received response to 100 message. Transaction promise and email listen promise have completed. Successfully sent the transaction to the orderer. And as you can see here, it successfully committed the change to the ledger by the peer. So what happens is first we propose a transaction to the peer, and then the peer accepts the transaction, and then it sends it to the orderer, and then orderer orders the transaction into a block and sends it back to the peer, and then peer commits it on the ledger. So now let's see if the ledger is updated. So we're going to use query.js to see if the ledger was updated or not. Okay, since we modified the query.js file last time, we need to change it to request all cars. So as we can see, we have the car 13 added here. It's a Honda Accord, and Tom is the owner. So we're gonna do next is we're gonna add one more car, and then we're gonna try to transfer the ownership of the car. So let's go back to invoke.js here, and let's add car 14, and let's do VW. Let's do red, and let's see who can the owner be. Ted. Let's set the owner to be Ted. Okay, we're gonna do node. What was that? 14, right? Do we see a car 14 here? Car 14, 013. Yeah, right here. Car 14, color red, VW, Passat, and the owner is Ted. Okay, so let's try to change the ownership of car 13. And let's say Tom sells the car to Ted. So here we'll use change car owner function. Let's make a transaction where Ted and Tom exchanges their cars. So owner of car 13 will be Ted, and owner of car 14 will be Tom. Okay, now we have done two transactions back to back. In the first transaction, we transferred the ownership of car 13 to Ted, and in the next transaction, we transferred the ownership of car 14 to Tom. So let's query the ledger to see if the ledger has been updated or not. So as we can see here, car 13 owner is Ted, car 13 owner was Tom here, and car 14 the owner is Tom here, and before it was Ted. So that's it for this session. We have pretty much covered everything. Not pretty much, we have covered everything in the for the Fab car application.